Happy to see you all again this afternoon, or whichever time zone you're actually in. As you heard, this is titled In the Eye of the Beholder, which is looking at repurposing mine tailings. For someone older like me, the better phrase might have been, one man's meat is another man's poison. And so that actually reflects better using mine tailings for lots of other interesting things, and that's what we hope to get to. First of all, I'm going to ask each of the four of you in turn to introduce yourselves, beginning with Mike.
My name is Michael Jingles. I'm the principal of Sunrise Americas and the director and founder of America's Tailings that I'll be talking to you about today.
Okay, Abe.
Hi, Abe Jalbout, the CEO of Auxilium Technology Group. Nice to be here.
Amanda.
I'm Amanda Dioshan, and I'm an associate professor in the geology department at Lakehead University.
And finally, Malcolm.
Hi everyone, apologies, my camera's not working, but glad to be here. Malcolm Shang, I'm the global head of closure planning for ArcelorMittal mining segment, as well as I hold the role of lead for circular economy within mining.
Great, thank you. So just before we begin with Michael's presentation, what I'm going to ask you all to try to do as you go through all the things you want to say is to try and help the audience to move away from mine tailings as fast as possible into all the wonderful things that can be achieved if we treated and used mine tailings differently. Everybody has the impression that these are very unpleasant materials and are just fixed the way they are, but we all know that there are many things that can be done that will actually turn mine tailings into a very positive attribute for the environment and for society as a whole. So with that, I'll hand it over to you, Michael, to take it away.
Okay, Douglas, thank you very much, and thank you much to the LIAMforum for the opportunity to talk to you today. As an introduction, America's Tailings is a private Colorado-based resource company. We've been collaborating with a technical partner based in California to produce an organic biomineral fertilizer from repurposed mine tailings. This is an innovative technology. It leverages the expertise and the knowledge of both the mining sector and the agricultural sector. The technology is currently being tested at a pilot level in Peru and at a small production facility in the United States. And the objective of those testings are to advance the development work to prove that the technical and commercial viability of the project at an industrial scale. Next slide, please. Despite Douglas's instructions, I think it's important to reference some of the challenges with tailings, in a sense to give you a scope of what we're trying to achieve here. And obviously, current and legacy mine tailing sites have major challenges. We understand that the requirement for containment and long-term management of tailing sites as a result of the mine processing, and often those sites can be perpetual, which makes an increasingly challenging environment for any mining company. Also, I think it's becoming very apparent the structural challenges associated with some tailing sites and the environmental issues. And again, it's been well publicized, the high-profile cases where you've had human catastrophes and environmental damage from failures of tailings sites. So, and finally, I think I just want to reference one more item, which is the challenges in some jurisdictions, and obviously I'm based in the US, and the challenge there of remediation and repurposing tailings sites, particularly because it's a case of touch it and it's yours in the States. Effectively, the owners, both the old owners and the new owners, are responsible for legally managing those tailing sites, not necessarily all at once. And that really acts as somewhat of a deterrent to some companies and to be proactive with new mine tailings initiatives. So I think it's important to have that backdrop there. What our value proposition is to consider these tailings are not as waste. So really the idea is that they not all sites for us, but they do contain nutrient value that can be found within them. And so as we approach looking at dealing with mine tailings, we're looking to take all of the tailings product that we need and to convert that into what we've described as this biomineral fertilizer. And to a great extent, that alleviates a number of the challenge with tailings. As I said, not every tailing site is the same, and they all have different characteristics and unique challenges. But in this case, we're able to reduce the footprint. We're also able to remove certain contaminants in the process. So that's really where we see the benefit to improving the current environment of the tailing sites. And I think further with the successful repurposing of the tailings, we hope not only to overcome those challenges, but I think we also hope to contribute to a sustainable future on a more general level. So if I could go to the next slide, please. There we go. So what is the process? The diagram here illustrates what we're trying to achieve. The tailings are combined with biomass material as feeds to produce this organic biomineral fertilizer, or what we refer to as a soil additive. Low concentration and trace elements in the mine tailings, which are traditionally considered contaminants, can provide important micronutrients for our fertilizer. The biomass is collected principally from a variety of food wastes and using biochar. And we combine these feeds into a digestion process which is intended to produce the fertilizer. At this stage, the design work for the digestion process is really based on proven operating practice and methodologies. And on top of that, we've layered new ideas to make it adapted and custom made for dealing with tailings as one of the feeds in there. And what we're trying to achieve at the moment is that we can build this process to an industrial level. I referenced the use of bench scale testing in labs and pilot plant, and even the small processing facility in California. What our objective here is to try and build this out to an industrial level so that we can meet the market for organic fertilizers. Next slide, please. So as I just mentioned, the bench and pilot work has confirmed that if we have the right type and combination of the tailings, the food waste, and the biochar feeds, the technology, I believe, can produce a commercial product with the right constituents that will allow us to participate, to be sold into and to participate in the global market for organic fertilizers. And I think everyone's very aware that the market is growing rapidly there. So there's the general constituents that we're getting out of this fertilizer we're producing. But we believe that the organic biomineral fertilizer that we will be able to produce will have important attributes in the sense that it should enhance growth performance in the crops. And with that, we're hoping that it can expand possibilities within the agricultural sector itself. So not just enhancing what we have, but that it'll open up new opportunities within the agricultural business. So beyond we've talked about the product there briefly, and obviously we're attempting to make a commercial business out of this, but how might this technology make a difference? Fitting the product into a broader sustainability of waste management and fertilizer production through the adoption of the circular economy. We're looking at enhancing local employment and business opportunities, as well as establishing a post-mining economy. For those of you not involved in the mining industry, what we're hoping is that this technology can be one of a number of foundations that can support and sustain a local community after a mine closes. Typically, what happens is a mine runs its life, be it a few years or 10 or 20 or 30 years, and the communities hopefully have made some financial benefits out of that period and the economic gains, but ultimately you get left with nothing, as it were, and possibly even some problems as well. What this may, we hope, be one of the solutions where we can encourage a local industry. We can encourage whether that be through the fertilizer production itself or through the crop growth and encouraging agricultural use. We hope that this may be a foundation for those sort of communities to be able to use this product, to be able to gain from that, and to have what we call the sustainable future from there. In addition to local food production, the products can also be used for reclamation, restoration, and carbon projects. Production and adaptation of biomineral fertilizer can produce the Scope 3 carbon offsets for both mine closure and community agricultural products. Healthy soils are also a prerequisite to achieve multiple UN Sustainability Development Goals related to economic metrics, food scarcity, health and well-being, environmental initiatives, and climate action. So this is the final slide, which shows the Valle Central in Chile, where we're planning to apply our technology to a new project. We've also listed our website there, and if you're interested in more details in America's tailings and what we're trying to do, I encourage you to go and have a look at that. So thank you very much.
Great, thank you, Michael.
Thank you, everybody, for the opportunity to present today. I'm very excited to be on this panel, and also with such thought leaders, and also the ability to connect with students and also young professionals. Auxilium Technology Group is an emerging technology group based in Tucson, Arizona, and our main value proposition is zero waste to zero emissions, using tailings to achieve net zero. So I'd like to go over a little bit of basic concepts and how they relate to mining, and also a little bit about how they tie into the kind of work that we're doing. So obviously ESG stands for environmental, social, and governance. And I just want to break that down into each different category. So E applies to things such as water management, mine waste, tailings, energy, GHG. And S applies to land use, gender parity, worker community health, mine closure. The G, legal compliance, ethics, and transparency. As can be seen from this simple slide, to achieve the objectives of modern mining, there must be a unity of different corporate values, as well as existing technological advances. The G in ESG therefore becomes an important factor for changes in the industry, such as mining. The point here being that there's a wide degree of cross-disciplinary collaboration. This includes software engineers in mine planning, metallurgists, chemists for processing of materials, mechanical, electrical engineers for almost every aspect of the value chain, agricultural experts, as we heard from also in the last presentation, which was a very interesting approach, for reclamation, legal experts for the governance aspects as well. And also I'd like to share an interesting statistic. So there is value in this pursuit. I do want to emphasize that. A recent article in the Canadian Mining Journal reports a 58% positive impact of improved ESG performance with financial returns. So that's a really encouraging statistic for why such issues and also approaching such problems become so critical in today's world, not just in mining. I'd like to discuss a little bit about our value proposition and also our main flagship product, which is called Entail, our tailings solution. So our intention is to act as a platform for the use of new and emergent technologies as well as applications. Our circuit utilizes all components of the input tailings feed to generate different products of value. Among these are unique carbon sequestering green building materials that we've developed, among other ideas as well, and also products. Entail is modular that is achieved through the development of pre-engineered components that reduce EPC costs as well as deployment. Through this approach, it allows for high replicability, implementations across different mine sites, as well as varying ore types as well. Our solutions are zero waste, utilizing all components of the input tailings feed. And the process itself is carbon negative, using a variety of biological approaches and also unique and proprietary CO2 sequestration methods. So together, these benefits allow for mine sites to achieve net zero using tailings. I'd like to go briefly about our different emissions and how we aim to address these using our solution. So there are many ways that we can achieve net zero using our regenerative platform for tailings. So we need, so for example, if we look at Scope 1 emissions, we're looking at things such as renewable energy production, including energy storage in the form of hydrogen and others. Water evaporation reduction becomes an important aspect to address Scope 1 emissions, backfill paste, cement replacement, of course, also carbonation of building materials. Scope 2, through purchase energy reduction, elimination using renewables. And finally, scope 3 emissions, which are indirect emissions, so things such as waste reduction, tailings as cement replacement, and also our new geofoam product, which can be used also as a CO2 sequestration building material. So we need a new generation of thought leaders to identify opportunities for the industry to improve. This is a message to also the students and young professionals in the audience, but that we need fresh ideas, initiatives, and diversity are important and essential for change. I do just want to close this out with a statement. Sustainable product regeneration is a key driver for the mine of the future. Thank you, everyone.
Very good. Thank you very much, Abe. We'll move on to Amanda.
Good afternoon. I'm really excited to be here, and the audience is probably too young to remember Sesame Street, and one of these things does not belong here, but that is very much what you're going to get right now. And it's how I usually feel in department meetings. But anyway, as mentioned, my name's Amanda. I'm in the geology department at Lakehead. I coordinate the water resource science program here. I am a research chair in biogeochemical cycling of carbon in northern soils, and I'm the president-elect of the Canadian Society of Soil Science. So that's a real mouthful of titles. So I was born and raised in Nova Scotia, and my partner is actually a commercial lobster harvester. We have 2 boys that keep us really busy. And I want to start off by sharing a little bit about my background, because I did my undergrad in biology, I did my master's in geography, and I found my way to earth science in my PhD. But focused definitely on the soil. So I've worked in the Caribbean and the Arctic and forest and agriculture. And one thing that is a common theme is disturbance, and how disturbance, whether they're natural or a result of our activity, affects how plant and soil systems function. And by understanding how those disturbances affect function and why it affects function, then we can understand how to be better stewards and return this material to the land. So one of my main messages is that we really need to be adaptable to changing situations, because that helps us to build resilience, both in our personal and professional lives. And I'm sure my colleagues here will agree with that. So at Lakehead, I'm a member of CEMI, and I was encouraged to talk about that a little bit. So CEMI is an acronym for the Center of Excellence in Sustainable Mining and Exploration, and it's a hub for industry-linked research and training. We have over 30 members, and research just spans a whole diverse range of faculties. And that allows us to bring a really wide range of opinions and viewpoints to the challenges of sustainable resource development, much the same as what we're seeing here today. So our work is built on 3 pillars, which is mineral exploration and mining, Indigenous engagement, and environmental impact. And our vision is to meet those human resource requirements for industry through the training of the next generation of skilled workers. And to act as an incubator for research for the mining sector to enhance stewardship, and to build trust and partnerships with First Nations. So our mission is to encourage and support research, education, and outreach in Northern Ontario to support the development of community-based research and outreach, to generate research projects that facilitate sustainable resource development in Northern Ontario, and to apply our outcomes to broader issues elsewhere. So by now you are probably asking yourself, what the heck is she doing in this session? And don't worry, because I asked myself the same question multiple times. So the truth is that I do have experience with the circular economy. That's a little bit tangential, but very much complementary. And it has benefits for mining tailings and for waste. So food and fiber production systems generate a lot of organic waste, or what we often call residuals. And I guess it's kind of like a compost of sorts. And in some cases, we can just apply that right back to the land. And it acts as an organic fertilizer. And what that's doing is, of course, replacing the nutrients that we removed when we harvested the material. So that has huge benefits for function of a system. We also can burn that material and that to produce energy. And how we burn, whether it's in the presence of oxygen or not, changes the chemical structure of the material. And that's just a fancy way to say it creates something that is usually quite alkaline that we can use to increase the pH of a soil or a water. Why we care about that is because a lot of nutrients are more soluble at those intermediate pHs. In other cases, it increases the surface area of the material, and that increases exchange sites. Well, what the heck are exchange sites? We'll just think of them as one side of Velcro, and the other side is things are going to stick to them. So regardless of whether it's ash or charcoal or biochar, these materials can be returned to the land for benefit. And in the case of this panel, we can use these materials to remediate sites that are impacted by mining in a way that maximizes economic, environmental, and societal benefits. Because these waste materials, they contain a tremendous amount of elements that are basically like vitamins for the plants and the organisms in the soil. And they can create, I heard Michael talk about healthy soils, which was awesome. I'm actually talking to the Senate tomorrow about soil health. And healthy soils filter water, they fix carbon from the atmosphere by supporting plant growth, they harbor vast amounts of biodiversity, and all of this can really help to reduce greenhouse gases in the atmosphere, which we know is a big problem. So in summary, it's really about turning a challenge into an opportunity. And so much today is all about mindset and changing your mindset. So with that, thank you, merci, and miigwech.
Thank you, Amanda. That was excellent. I know you were worried about this, but you had no need to be worried at all. So we'll
Thank you.
move on to Malcolm. We're going to come back to you actually later in a bit, but let's hear what Malcolm has to say. I don't think he has any photographs or pictures to show, but he can explain what he's all about.
Thank
you got
you.
that?
I actually do have a previous presentation that might work quite well for this. Simply, the circular economy presents a number of different opportunities, so not just for the mining industry, but for other industries in general. And there's a very big momentum behind this concept right now, which is very nice to see. And as you can see, there's real economic benefit. There's estimation of 25 trillion by 2050 if it's actually fully adopted. For the mining industry, is it a threat or an opportunity? It's both, in my opinion. Obviously we're reducing the demand for raw materials, but the future demand for raw materials isn't going away at any point in time. So it's essentially it is a bit of a threat, but also an opportunity, such that if we actually embrace the circular economy, we essentially become what we can be, instead of primary producers of materials, to material stewards. It's an opportunity to, in my mind, be disrupted or be the disruptor. Just going to go through this quickly. ArcelorMittal, it's the second largest steel manufacturer in the world. And on the mining side, we really focus on iron ore as well as metallurgical coal. But we made a number of substantial commitments as a company to essentially build smarter steels and become low carbon, net neutral, net zero by 2050. The great thing about the circular economy is that it really links into our goal to be net zero by 2050. And I'll move on to the next slide to link that. The keys are the key circular economy principles, as you can see on the left-hand side. And very simply, you can see how they link with what we call our net zero levers to get us to carbon neutral by 2050. So you can really see the circular economy is not just about materials and making sure the materials stay within the system. It can really help us move and achieve our climate goals. This is really just showing, in terms of the circular economy, it's really about where you sit within the value chain, and very simply what you can control versus influence. On the mining side, I won't go into too much detail about this, but we are exploring low carbon energy transition initiatives. There are some potential opportunities we've spotted in terms of not just tailings, but our waste rock. I will echo a lot of what the other panel speakers have said. So what it's really about is looking at our waste from first principles. Being an engineer, I tend to look at everything through the first principle lens, and it's really about breaking it down into its constituents and really seeing and exploring across industries as well as within our industry in terms of other uses that we may not have thought of. Essentially, I see it as an evolution of mine planning. Right now, mine planning is really focused on a specific commodity or a number of specific commodities, but everything else besides those commodities is seen as waste. If we actually spend a little bit of time during the planning phase exploring our waste with a little bit more curiosity, and then also spending a bit of time exploring uses, not just within our industry, but across industries, we essentially have the opportunity to unlock literally substantial value, not only for our mining, for the company, but across the region that the company operates. Some lessons from the energy transition. So we've actually invested substantial amounts in our pellet plants in Canada on our mining segment side to essentially reduce our CO2 emissions. So there's a substantial amount of work that we're doing there. There's some very interesting lessons from our steel production side, which we've implemented the circular economy. This is a really great example whereby a little bit of exploration and creativity can come up with some really great new use cases as well as new revenue. So this very simply is what we call circular carbon. There's carbon-rich gas as part of the steel making production, and very simply, it was identified and studied with a company called LanzaTech that essentially a microbe or a number of microbes could turn that carbon-rich gas into an ethanol, which then could be used as either a biofuel or to create other several products. And we're really at the start of really exploring this, but as you can see at the very bottom, the potential revenue is substantial by essentially unlocking this value from the waste. Another great example, and it really speaks to what the other participants were speaking about in terms of tailings. This is slag, but very, very similar sort of concepts here. So cement, we built a road in India using it. Interesting thing, it's actually more durable and also 30% cheaper. It also saved a lot of emissions from the use of slag in place of I guess, the typical cement. That's really saving the amount of cement that would have to be made. And then it also has some other advantages, which on the right-hand side, so there's actually some studies being done in our Brazilian operations in terms of how the slag, which has some key minerals, could also be used to regenerate coastal reefs. And it's not just us looking at it, but this is not our example, but that's another one from the industry, one of our competitors. But essentially, there's some ongoing studies in terms of the use of slag in terms of coastal reef restoration. Like the other participants were talking about in terms of tailings, this is different because it's slag, but application in terms of at least the nutrients within that material for essentially agricultural use. And the last thing I'll say is that we see a big growing market in terms of scrap steel. This is another obviously segment of the circular economy in terms of recapturing that material and reusing it. Not only do we see this as a great growing opportunity, but it also lowers the carbon footprint in terms of our steel making production, because when we use more scrap in our production, it lowers the carbon footprint. There's a couple of lessons, but I won't really go into these too much. It's really about this talk was given to the industry, and it was really about finding champions and supporting them and spending a bit of time and money and investing in them. One example I will highlight is the third bullet point. It's a great example in terms of the circular economy. Through the lens, I think it really unlocks not just opportunities at a local level, but at a regional scale. Because you're forced to look at problems not just locally but regionally. It's a great example in Chile. There's essentially oversized tires at a mine site are a common problem. And typically, if you look at it, if the problem from just one site's perspective, it may not be economically viable. If the area and region is dense enough in terms of waste material, it may be an opportunity for a company to invest in building a recycling facility there. And so Cal Tire, as well as Michelin, have done exactly that in a region in Chile, which very simply they collect the old tires from the region, from different mining companies, and convert that into original materials, being carbon black, which is a type of, I guess, a base material used for rubber making, as well as steel and fuel oil. Very simply, this opportunity may have been missed if you only looked at the problem from a single mining company or a single mining site perspective. So essentially, the circular economy forces you to look at it from not just a local site lens, but also a regional lens, and also through the lens of potential other industries. The last things I'll leave the audience with, at least in terms of my my soapbox talk right now, is it's about being curious about waste and inefficiencies in general, and also thinking about how you can potentially design your waste. If we actually found an end use for the waste before we actually created it, we increase our chances of the waste actually becoming a commercial source during production, not afterwards, which would require potentially additional secondary treatments. The last thing I'll leave with everyone is very simply, an old professor said to me, one of my university professors said to me, that there's really no such thing as waste. It's really a resource in the wrong time, wrong place, or wrong state. And I think just thinking about waste in general, whether it's material waste or energy inefficiencies or even human capital, there's a lot of new opportunities and innovative ideas that can come from that just by changing the way we view the problem. And with that, I will open it up back to the rest of the panel.
Thank you very much, Malcolm. That was a very good closure on the whole piece. Basically, what everyone here has said this afternoon is basically we have to take a much more holistic approach to the materials that we call waste. There really is no such thing as waste. It's only a material for which we have not found a particular use yet. And as you've heard from the people that we have presented, there are lots of different solutions being sought by many, many different people, and you've heard from 4 of the best this afternoon. So I just wonder, because we're going to run out of time shortly, rather than go back to some of the technical issues, because you've all addressed them very comprehensively, I wonder, since Amanda gave us a little taste of how she got to where she is and described her pathway to where she's ended up, I wonder if the rest of us might not do the same thing. Michael, maybe you can tell us how you started off your career and how you ended up where you are.
I guess I remember my first job was in London, and I was hired. I finished my degree, my master's, and my first job was an intern in a disused office in the centre of London on a floor, rolling and documenting about thousands of maps for about 3 months. So that was the start off. And my second job in the industry took me to Australia, and about a 10,000-mile journey with no invitation and no job offer to go and seek out work on another continent. So I guess my learning from that, and we're running through interesting times as we move out of the COVID, and a different world where we're running off screens, where a lot of people are working remote and at home. There's less travel in general. I think we all know what we're experiencing and what everyone is experiencing, and I think the message there, and somewhat with tailings as well, is don't be limited by what you see as a barrier or a hurdle. You can change that paradigm or that dimension by thinking out of the box and taking those things on. So maybe we don't all accept what we have at the moment, let's say, and hopefully the future is a little bit brighter than a set of screens.
Yes, it certainly is. Mike, thank you. Abraham, where are you coming from? Where did you come from to end up where you are?
I actually started out as a biology major. I wanted to be a surgeon. that didn't work out. So I went to chemistry and also physics, just different, I guess, curiosities when you're still at that age when you can really explore different things. From there, actually, I went to work in astrobiology, so nothing to do again with mining, after my PhD work. Then a mentor of mine told me to work that there were interesting challenges in the finance industry. So I pursued that and actually made it quite an important part of my career. I established an algorithmic trading fund and basically did that for a number of years. And in parallel was also this curiosity of identifying new ways to repurpose a lot of issues in the mining industry, namely mine tailings. And that's led me to a 10-year obsession with mine tailings and anything related to waste, and also to where I am today. So I just want to leave the audience, and especially the students and young professionals to be, I think it's important to be solution-driven rather than discipline-driven.
Very good comment. Thank you very much, Abe. Malcolm, how did you end up where you are? When did you start?
Studied civil environmental engineering. Didn't expect to be in the mining space. That's where I ended up being. The interesting thing is that there's a lot of challenges in the mining space, and coming from an environmental engineering solution-driven background, you're sort of forced into a industry which hasn't had the best reputation in terms of innovation, but that allows the opportunities there to question and critically analyze how we've been doing things to come up with new ways of doing things. So what I would encourage is the students and young professionals right now is really focus on value add to a company and an industry. Doing things the way they've been done, it's not, sometimes the original assumptions no longer apply. So it's very important to continue to question why things are being done a certain way, and as the other guests have said, are there potentially new ways and better ways of actually doing that? So don't be scared to question how things are being done. In terms of my curiosity, it's led me to a number of different, I guess, professional certifications, sustainability, macroeconomics, etc. I would echo some of the other speakers in terms of don't be scared to have a bit of a varied career path and other interests. I think it's the cross-pollination of ideas from different perspectives that really leads to innovative problem solving and unique perspectives to come to new solutions. So yeah, it's a bit of a, I guess, a roundabout way of saying don't be scared of exploring your different interests and bringing that to your working environment.
Thank you, Malcolm. That's another excellent comment. So for the audience out there, what you've heard are 4 people with widely varying backgrounds arriving in very, very similar destinations, but also people who did not, for the most part, intend to end up in the mining business or trying to improve the mining business, but have ended up there. What I basically should say to all of you is, it matters much less today where you begin, depends on where your own passions will take you. I can finish off with one of my own background, which was I went to university because my father insisted that I not end up in the mining business, which in Scotland was in the coal mining business. And so I ended up in geology and geophysics. And I was heading to university in Germany to study fossil sea urchins and the structure of fossil sea urchins, some of which produce tunnels in the clay on the seabed. And from that, I diverted my attention from the actual sea urchins themselves and the tunnels they make to the tunnels in mines. And so I ended up working in mines and have done for the last 40 years, mostly in underground mines. And then at the end of my career became more involved in tailings and waste management because it's a very large part of what holds the industry back. But everything we've heard on this session this afternoon and in some of the earlier sessions, in fact, almost all of the earlier sessions today, you can see and hear how rapidly this whole field of managing waste streams in the mining industry is changing. And it will continue to change increasingly quickly. And we need many, many young people with lots of passion and lots of interest in how to change it faster. So we're still in a place where industry is changing relatively slowly. That is accelerating, and we're going to rely on all of you younger people out there to join in whichever discipline you come from to help move the needle forward in many, many different directions. And I think with that, since we're the last event of the day, we can close off with that. So thank you very much for attending, and have a good day.
Yes, thank you all so much. I just want to thank Douglas and Abraham and Mike and Amanda for joining us in this session today. The resources and the tools that have been given during this conference have been so useful, mostly for someone starting out in the industry. It sounds like now is the best time really to be joining the mining industry with this huge forum that we have going on as well. It really couldn't have come at a better time. So I truly believe that this will help with anybody that's starting out their career. So I thank you all so much for joining us today.